Historically, the conferences that we have done on manufacturing have been about manufacturing technologies, and I know that's important, and this is the Massachusetts Institute of Technology. We've spent a lot of time talking about managing through disruption, and we're going to talk some more about that this afternoon, and even some of the talks we're going to have now will do that. But we do want to get you your technology fix, and the MIT Connected Startups that you're about to see are going to, I'm sure, wow you. I will not do the introductions. I will introduce my colleague, Ariadna, who will introduce these startups for you. Prepared to drink from the fire hose because there's going to be an awful lot coming at you in the next 40 minutes or so. Ariadna?
Thank you, Ron. And welcome everyone to the Startup Lightning Talks. I'm Ariadna Rodenstein, as Ron mentioned, events leader with MIT Startup Exchange. And welcome everyone, great to have you here and remotely. So I will give a brief overview of our program, and then we will hear from 10 startups today on their exciting and innovative technologies. You have probably met a few of them already out at the exhibit. MIT Startup Exchange was created 7 years ago with the goal to help promote partnerships between MIT-connected startups and industry. We have 1,400 of these startups, and they're based on MIT licensed technology, or founded by MIT faculty, staff, or alumni. And we have 240 members of the Industrial Liaison Program, or ILP, as you probably have heard. These are global 1,000 corporations that cover all industries and all geographies, and represented by many of you here today. And so how do these collaborations happen? They eventually become successful partnerships, and I hope that some of the conversations that start today will lead to some more successful collaborations, and we can even have you up here, this slide, in the near future. These are some of the trending technologies at MIT, and I've highlighted some that will be touched on by the startups, including artificial intelligence, virtual reality, big data, IoT, robotics, and sustainability. And how can you engage with the startups being an ILP member? One way is to join us at events like today's. You also have access to being introduced to them via your ILP program directors throughout the year, and also access to STEX25. That is our accelerator program for industry-ready startups. And we'll be unveiling the latest cohort later this spring. And actually, you can meet some of them already on May 4th. Hopefully, you can join us then. We're going to have the Ecosystem Conference at the Marriott just a few blocks from here. And finally, you can post opportunities. These are challenges for the startups where they can apply. And if you see a good fit, they can work with you and help you solve a problem that you're facing in your industry. So I hope many of you have been taking advantage of these benefits. And if you have any questions about them, please come to talk to any of us in corporate relations. And with that, I think we're ready for the startups. First is Dan Paluska, co-founder and chief robotics scientist at Pickle Robot. Thank you.
Thank you. How's everybody doing today? My name is Dan, as she said. I mechanical engineering undergrad and grad student and PhD dropout here at MIT. And so what are we working on? We're working on this idea of logistics in the warehouse, and specifically related to employee turnover. I visited a customer last week that we were piloting, and this customer informed me that in the peak summer, when it's hot in their warehouse, these shipping containers, they have to unload, go to 130 degrees, and they rely on temp workers to get the work done. And the average amount of time that a temp worker lasts is 3 days, where they have to have a new one. And they've had people come in, work for 2 hours, go on break, and then not come back. So this is a prototype from our office in Cambridge, but this is what we just got back from piloting the next version of this at a customer site in California. So we've got an array of cameras and sensors and doing some amount of machine learning, deep neural network stuff, not that dissimilar to what self-driving cars are doing. Combination of RGB data, point cloud data, making sense of the scene, and then the robot is carrying out actions to unload these boxes from the back of this, in this case, mock truck, but in the case of the California site visit we just did, was a real shipping containers full of products. This is a $50 billion a year market and growing 20% per year, and basically everyone has this labor shortage issue. Yeah, so we did release a smaller product about 15 months ago. We have a small handful of those running around the country right now, sorting thousands of packages every day. This is a customer in the Virginia area that has one of those. It's a small fulfillment logistics company, and we just got back from this production pilot of the large unloading robot that I showed you a little prototype video of earlier, and that was in suburban Los Angeles area. We've had over 1 million production picks so far, and no customer churn, which has been great. Yeah, so what are we looking for here? We're looking to connect with people who have these issues of worker burnout and staffing issues. And you've got the loading dock is this place where containers are coming and going, and trucks are coming and going, and that is where we're focused on adding our automation technology. So those are the people we're looking to connect with. Thank you. Is there a final slide? Oh, yeah.
Okay, let's see. Well, good morning, everyone. I'll get a little closer. How's that? My name's Dave Sossen. I am an investor in and an advisor to Coventry Associates. The company was founded by Craig Gardner, who's an MIT alum. He's also the inventor of the technology you're about to see. We're both MIT alums, and we met here at MIT through another one of the entrepreneurial ecosystem programs. So first question, really the only question you have to answer. What is the common element amongst these 5 pictures here? Wind turbines, an electric car, an electric truck, an airliner, and a CNC machine tool. So I'll answer it. The common element is high precision rolling element bearings. The rolling element bearings constitute a $30 billion with a B dollar global market. They're in everything that turns. And this is where we're focused. On the upper right, you see a typical ball bearing assembly. On the upper left is an exploded diagram. Where we work our magic is on the outer ring and the inner ring, and you're going to see in a second how that works. So here's a video. You see 3 tables stacked on top of each other with a grinding spindle on top and a grinding wheel attached to it. And in a second, the animation is going to start moving, and there it goes. We're dressing the wheel, putting a shape on it, and then we're grinding one of those rings that I alluded to a second ago. There it goes again, just repeating the cycle. Here it is in real life. It really works. All the flames and sparks are demonstrating we're really grinding metal away from the part. Normally, there's coolant, which suppresses all that, but we turned it off for dramatic effect. So that's that. Now, that was our launch product, but since then, we've developed a second product called the EPS multi-tool. EPS stands for Eccentric Positioning System. It's basically the same positioning system, but instead of doing a single operation, it can do an unlimited number of operations, limited only by the size of the machine you want to build and how big the building is you can build around it. Typically 3, 4, 5 operations on a typical system. Here you see it set up to do a rib spindle, an outer diameter spindle, and an inner diameter spindle, which are the 3 operations you typically have to do to make yourself a ball bearing. So now we get closer to the heart of it. What's it worth? So if you want to make ball bearings today, you need to go out and buy at least 3 big machine tools. There they are. They're typically each made by a different manufacturer. They don't integrate well together, and they each cost about $1 million a piece. And that's before installation and training and all the other stuff. Our machine does all 3 of those operations in one fully integrated, highly robotic system, and it costs about $1.5 million. So just capital expenditures alone, you're saving $1.5 million. So that's great. But what's the real impact? Well, we were asked to show what a customer situation looks like, and it looks like this. So this diagram is from a large manufacturer of ball bearings and other kinds of bearings. And I won't ask you to decipher all that. The point is, on the left side of that diagram, you see a schematic of one of their 500 production lines that they have globally. It's a very big company. On the right side is what that production line will look like, we hope, when they replace that stuff on the left with our technology on the right. Now, on the left, there are 11 machine tools, so round figures, $11 million of capital equipment, and 14 technicians to do the operations required. On the right, with the Coventry technology, it's reduced to 7 technicians and 5 machine tools. So 50% savings in labor and plus 50% in tools. What's it worth? Well, as I said, company is very large. They have hundreds of assembly lines globally. Typically in this industry, you turn over machine tools every 10 years. They wear out and either have to be replaced or rebuilt. We've done a projection with our customer that if over a 10-year period they replaced all their existing grinding technology with ours, they'd save $5 billion. That includes the labor savings and the CapEx. So we think it's worth doing. And I haven't touched on the performance advantages and the green advantages, which are significant for lack of time. I've got 4 seconds. So we seek introductions to, obviously, precision rolling element bearing makers. Anybody, anywhere in the globe, we're happy to talk to. We are talking to several, but there's some, particularly in Asia, we can't get to. And machine tool makers who are both our competitors, but potentially also our partners, and in the longer term, even maybe an acquirer of the technology of the company. Thank you.
Good morning, everyone. My name is John Greenfield. I'm here representing Everactive and here to tell you about how we believe we can unlock more than $1 trillion, which is trapped in factories today. Our connection to MIT is that our 2 founders are PhD electrical engineers from here. They're now professors at the University of Virginia and Michigan, respectively. So Mark Andreessen, this quote might be familiar to some of you, said famously about 10 years ago at this point that software is eating the world. We agree with that, and we extend it to say it's still quite hungry. From our perspective, this is most evident within the manufacturing segment. That's why we're here today. It's why I think most of you are here today as well. And as you can see, it's not just us who believe that there's a tremendous opportunity here. This is a recent study that was released in the fall from McKinsey. And in order to unlock the value that we believe is captured here, especially within factories, we believe that there's a new approach that's needed, what we're calling hyperscale IoT, to bring the IoT to its full potential, the potential that we and many others have believed is possible for quite some time, but just haven't been able to get to yet. So what does that mean? From our perspective, it really means many more data points and and that can be both in terms of time and in terms of space. So being able to deploy sensors and data collection devices in more locations, but also get more frequent readings from them. What are some of the things that are preventing us from getting there today? We see kind of 4 key ones. One is, of course, we all don't like charging our phones. Similarly, folks in manufacturing environments, probably some of you have these challenges too. don't like replacing batteries or sending people around just to change batteries. So that's a key one from our perspective. The mismatch between the existing wireless standards and the manufacturing environments is a second. Obviously, high integration costs because there hasn't been a lot of integration to date. And then finally, the difficulty around proving ROI within these environments. So use cases, and use cases. So from our perspective, one of the key reasons that all of these things are still issues is because all of the solutions that exist today, or most of the solutions that exist today, are built on top of the same COTS hardware. So from our perspective, what we focused on was rebuilding the hardware from the ground up in order to better match these kinds of environments. So we build energy harvesting wireless sensors that go into industrial environments. They communicate with a proprietary technology. They don't require batteries to operate, and they're scalable. So again, getting back to that idea that you can put these devices in many more places, you're not gonna have to go back and change batteries, and they're gonna collect more data for you during that time. And then finally, the ROI. So we started with 2 specific use cases. Those are the ones that are shown here. 2 full stack products to demonstrate the value of the core technology within these environments. The one on the left is focused on steam distribution systems, and the one on the right focuses on rotating equipment, taking vibration data, processing at the edge, and then presenting alerts to our end users, some of whom you see below, in order to know when they need to go and take action on that information. Each of these applications alone is a fairly large market. So this is approximately a $20 billion market from an annual recurring revenue perspective, which is generating or has the potential to generate over $50 billion in value for these organizations. So each of the logos below is an existing customer of ours. It's a place where we already have the infrastructure and the network installed, which means that for rolling forward for the next applications, those are now available to developers in order to take advantage of. I think one key thing and a thread that we were excited to see run through the conference today, is the fact that sustainability and manufacturing, from our perspective, don't need to be opposing forces. In fact, they should really be integrated. So our solutions today are helping to, first of all, quantify the ESG opportunity, but then secondly, and importantly, actually have an impact. So by monitoring the systems that we are today, we're helping to remove batteries. Obviously, that's a kind of a critical one. But then in addition, because we're monitoring steam systems and motors and other industrial equipment, we're helping to reduce quite significantly CO2 emissions as a result of that. So again, we see the tie between the two. So finally, what are we looking for today? We talked about the 2 applications that we've developed ourselves. In addition to that, what we are focused on now is opening up the technology so that other people, we think of them as application developers, they can look like industrial OEMs, system integrators, others, can use this very proprietary and special hardware in order to, and take advantage of the networks that we already have in these environments, in order to bring the 3rd, the 4th, the 10th, and the 15th energy harvesting solution to this kind of market. Because from our perspective, the market is very ready for it. So please come see us afterwards. Our VP of Marketing, Brian, and I are both here. We'd love to talk to you about becoming either a developer and building with Everactive technology, or an end user and adopting some of it. Thanks very much.
Hi, I'm Kimo Johnson, co-founder and chief science officer at GelSight. Today, human hands interact with objects in the world 1 trillion times per day. Many of these interactions are a fundamental part of business, from manufacturing goods, to inspecting objects, to packing boxes. And many of these are manual and have not been successfully digitized. Over the past decade, there have been tremendous advancements in AI on vision and audio data, but vision alone is not capable of providing a full understanding of the physical world. The core idea behind GelSight actually came from my postdoctoral advisor as he watched his infant daughter interact with the world through touch. He started thinking, what is the signal that she's getting out of her fingers, and how can we digitize that? And it was that idea that led to the creation of the GelSight sensor, a soft, high-resolution tactile sensor with an image sensor inside to capture detailed digital data. So during my postdoc, I helped develop the core technology, and then about 10 years ago, spun the company out with some co-founders. We've been very active in developing the technology for surface analytics, but in fact, we see much broader applications for it. So we're building a tactile intelligence platform that combines our core sensing technology with an artificial intelligence framework to develop diverse applications. Our flagship product is the GelSight Mobile, and this is a handheld surface inspection tool that can go down to the factory floor for making micron to millimeter scale measurements. It's commonly used for inspection, process development, quality control, but really what it's doing is it's replacing human hands in some of these applications where people were feeling components to try to decide if something is in or out of spec. Now we can have a detailed digital measurement. We've also developed different versions of the technology. In the center, we show a robotic finger that can go on a gripper and give robots a sense of touch. It provides information such as the pose of an object in the grasp, if the object is slipping, and this kind of tactile information is really essential for automating many tasks that are done by human hands today. And finally, last year, we introduced, in a partnership with Meta, a low-cost version of our technology called the Digit sensor. This is a sensor that's getting out into research labs all over the world, and it's designed such that people can get an experience with GelSight technology, and it's our vision that we want this technology to be the gold standard for tactile sensing. How does our technology compare to other technologies? Well, in the space of tactile sensing, we have unique advantages. It's soft, like human skin, but yet high resolution, which is very well matched to AI frameworks and a lot of stuff that's being done in deep learning today. In terms of surface analytics, the ease of use and the fact that our technology is insensitive to the optical properties of the material are really fundamental to our competitive advantage. It can be a handheld tool that goes into the hand of a union operator, and they can instantly get micron-level surface measurements without having to go to a measurement lab. What are the common use cases? Well, the most common use case today is, as I mentioned, doing surface measurements and inspections. And here's a picture of people using our system to inspect aspects of a wing. We have systems deployed to aerospace, automotive, and many different industries. Anytime where there's a little imperfection that needs to be characterized, it's a good match to what our system can do today. And in fact, we had one executive at Rolls-Royce say they don't know of any other tool that has the ease of use of the GelSight instrument. But thinking bigger, of all the places where human hands are used in manufacturing and other processes, getting our technology into robotic grippers such that the robot can feel the objects, that's really the next level of interactions. And in this image here, we're showing a partnership that we have with Magna Automotive, where they're deploying our technology into intelligent grasping. How can the robot feel and react to objects as it's grabbing them? And we see a lot of potential in that space. So what are we looking for? Well, this is a platform technology with lots of uses. If in your organization there are human hands being used for tasks, and especially things that are monotonous and things that, in fact, it's hard to find people to train to do these tasks, it could be a good application for GelSight technology to automate that tactile information. So whether it's surface measurements, analytics on surfaces, or, in fact, robotics tasks where people are moving things from one place to another or doing dexterous manipulation of objects, this could be a good example of where our technology can apply. And we have a live demo out there. We can give you a first-hand view of what GelSight is like, and we'd be happy to tell you about all the applications where it's being used today. Thank you.
Good morning, everybody. My name is Cyrus, and I'm the CEO of Leela AI. And we have deep roots at Leela AI at MIT. My co-founders, Henry Minsky and Milan Minsky, come from deep AI backgrounds. And you're up here at the Media Lab in the 90s, so it's great to be back on my old turf. And today I'd like to tell you a little bit about what we're building at Leela AI. we call it resilient AI solving real world problems. And one of the most real problems that we've found, and one we really want to solve, is a problem of understanding what is going on in manufacturing work areas. The reason this has been hard is because time to value is actually, if anyone's ever, has anyone ever implemented a machine vision solution in a factory? If you have, just raise your hand if you'd like. Okay, we have some, thank you for admitting that, appreciate that. Then after this, tell me if I'm right about this, but you might have had some experiences where you collect some data from your specific needs in your industry in this facility, then you pipe those into a pipeline where you have usually people collecting the data, labeling the data, then training a model, validating the model, and then after that, it gets deployed, and then what usually happens is there's some unexpected, unexplained decisions coming out of this system, either falsely identifying with a false alarm or missing things, and then you have to go back and collect more data, relabel that data, retrain the model, revalidate everything, and then you end into this really very long-running spiral of cost and time being spent on getting to some value. It can take months and hundreds of thousands of dollars. So that, to us, was something we really wanted to help, and the way we thought we could help is if we could do this better, faster, cheaper, with less data, that would really advance machine vision in the factory. And so we created our product Understand Video, which has a no-code, human-teachable interface, which you can see here, and this lets us quickly create new use cases, new custom activity understanding systems, and requires a lot less data. You can build a use case in hours instead of months. You can deal with multiple cameras all over a location or different locations around the world, and it's easy to adjust and improve. So instead of having to wait for an engineer to come fix things, our customers can fix them themselves. So that's really a breakthrough, we feel, and has sort of made, finally, we think, machine vision useful for manufacturing. So here's an example of what comes out of our system. This is just with a couple of days of work trying to teach our system the tasks going on in this facility. It now understands when people are welding, where the welding tanks are, where the material is, and all this kind of different level of detail. And so after that has been set up, our customers can log in and see what is happening at a very highly granular level. And that includes which tasks are happening. And here, green is welding, purple is walking, and gray is standing. And so what % of time during the day was spent in all these activities? And that translates in the value-added activity count as what % of the day's time was spent doing value-added activities versus non-value-added activities. So it's a great way to quickly start doing continuous full-time value stream mapping, which has heretofore been very difficult, especially for these kind of environments. We also work on other kind of environments, but this complexity, the lack of structure in a big factory area with lots of people working has been a point where our customers said to us, you know, I thought I was going to work at this factory and I was going to have lots of great data to work with and I can do all this great stuff with this data. I got to my job, no data, no way to get the data, no way to measure what people are doing and how long they're doing it. So when they see this, they say, oh my God, now I can suddenly use all my knowledge about how to work with data, but not just from the machine output, from what people are doing. And this is, I think, a big breakthrough for digitizing factories and going towards Industry 4.0. So some of the benefits, understanding where and when non-value-add activities are happening, and this gets to the Ben Armstrong's discussions today of labor. We need to help our customers, and we have goals like increasing labor productivity by 20% over 6 months. If we can increase by 20%, by understanding how much time is spent on non-value add, that's a big breakthrough. And this is the really only way we think people are going to get the data to do that kind of work. Better resource management, labor-intensive industries, labor shortages, better ways to manage those resources. We're working right now on our next release, which will start suggesting well, if you move stuff around, or if you had a shorter path of walking, or all sorts of suggestions that will come from our system, so it'll support industrial engineers who need that kind of support, sifting through millions of data points. Where's the efficiency to be found? We can suggest that, and also detecting anomalies automatically in activity. So today, if you are looking to partner with us, we have a cloud video solution. It's very easy to set up, and you can work on efficiency issues, continuous improvement, load balancing on lines, reducing injuries as well, because we do understand also not just what you're doing, but if you're doing it safely. So there's a lot of safety applications out there. And if you have a tight continuous improvement loop you like to work on, and you like to begin with or without your own infrastructure, we provide the cameras for free with our service, so you don't have to buy cameras. Come talk to me. I'll be outside during the breaks and all afternoon. I'd love to talk to everybody here if you like, and show you a demo at our table, go into depth. So thank you for your time today. Also, feel free to email me.
Hello. Hi, I'm Elise Jones from Tulip Interfaces. Our MIT connection is also very robust. Our 3 co-founders were all either MIT graduates or current MIT faculty. And additionally, a little over 30 of our product and engineering team are also MIT graduates. So Tulip has built a no-code connected application platform for the frontline operations workforce. So what this means is that we've taken a product that has existed for a very long time in a very specific way and created ways to connect it, digitize it, and make it easier to use and to empower the workers who are the closest to using it and right on the shop floor. Our platform is based on 4 core components. We have the app editor. Most of our applications are configurable and can be optimized for individual needs for different companies. We also have edge device and connectors to edge devices so that it isn't always just a complete rip and replace, but we can work with your existing components as well. We offer real-time analytics, insights into what is happening directly on your shop floor, as well as global sites elsewhere. And we provide community resources, so you can connect and find information on apps built by other companies, other practitioners, and other folks who are using similar systems. The kind of core component of our product are these really tailored and configurable apps. So they are individual, they come in app suites as well, and you can simply drag and drop in a no-code interface, allowing that backlog or bottleneck that can happen when you need to rely on your IT department or the vendor or provider to make those changes for you. It can easily be done right on the shop floor. Good example of a application or an implementation that we had that was a complete from the ground up kind of next gen MES solution was with PFF when they decided to invest in operating system to build their personal robot. Very cool thing if you've seen it around. And instead of kind of going with a traditional, large MES system, they decided to work with Tulip to be able to build, their entire process with this sort of agile work environment that could easily be configured and changed, especially with the sort of supply chain issues that have been occurring and being able to be flexible and move quickly with uncertainty. So our ask here is we really are looking for companies and individual practitioners to kind of join our trend toward digitization and connectedness in the front-end operations. Our business is going to be more successful if there are more people who kind of believe in this idea. We want to have practitioners across industries, including discrete manufacturing, food and beverage, and pharmaceutical and life sciences manufacturing. We want to continue to scale partnerships that we have and reach more instances that can be used for these applications, and of course, adding new partners, globally. Thanks.
Good afternoon, everyone. My name is Emily Malina. I'm a graduate of the MBA program at MIT, so great to be the MBA program at MIT, great to be back on campus. I'm also co-founder and president of Spoiler Alert. And we focus on eliminating waste within the food, beverage, and consumer goods industries. We do that by partnering with manufacturers to manage excess inventory and help them more effectively sell it to value channel customers and nonprofit organizations. And why we do this is because excess is inevitable. If the last 2 years have taught us anything, it's that demand planning and forecasting are hard. On top of that, products are discontinued, seasons and packaging change. Supply chain teams are left holding the bag with excess, short-dated, and obsolete inventory. And of course, when there's excess, the goal is to sell as much of it as possible. Common strategies are discounting, promotions, liquidation. When done well, inventory is moved quickly and discounts are minimized. But the reality is, within large manufacturing organizations, there are a lot of stakeholders that are involved in this process, from sales and supply chain to finance and fulfillment. And we find manual interventions, approval processes, and legacy systems slow things down. Slow-moving inventory has a number of consequences, especially when we're talking about perishable inventory. It impacts the price at which it can be sold, as well as the ability to sell that inventory at all. This results in some pretty shocking industry stats. Within large food and beverage manufacturers, less than half of distressed and excess inventory ends up being sold, and that which is sold is transacted well below cost of goods. So enter spoiler alert. We are the industry operating system for B2B liquidation sales. We work with large global brands, Kraft Heinz, Nestle, Mondelez, Campbell's, and help them to more effectively sell this excess inventory into the value channel. For the brands, this is helping them sell inventory faster, at greater value and greater volume. And for their retail partners, this means more shelf life, earlier access to inventory, and a better customer experience. How we do this is by introducing a number of workflow automation tools that our customers love. We eliminate a lot of the manual steps from the end-to-end process, from identifying this distressed inventory straight through order generation, and we introduce intelligence where it matters, such as setting pricing as well as optimizing freight. To boil it down from a tech standpoint, there's 3 key steps to the process. First is that manufacturers are able to automatically flag distressed inventory and send it to spoiler alert, indicating which customers are able to access which products. Second, buyers are able to determine the optimal assortment for their purchases, identifying the products they want, the quantity, and at what price. And the third, which is where the magic happens, is that supply chain teams within manufacturing organizations are able to determine the optimal allocation of that excess inventory from a profitability standpoint, a freight standpoint, and also a customer relationship standpoint. So that's how it works. What's the impact? Well, the 75% decrease in the time to market is a lot of what makes this possible. By eliminating a lot of the delays in identifying this inventory and flagging it for customers, the brands that we work with are able to sell significantly more of this excess inventory than prior to working with spoiler alert. You'll see here an average of 50% increase in the revenue generated from these types of programs. And to make this a little bit more real, a snapshot of our latest case study with Danone. They're one of the largest food and beverage manufacturers in the world. They specialize in dairy and other highly perishable plant-based products. And relative to before working with spoiler alert, they were able to decrease the time spent on these types of sales by close to 70% and increase sell-through by 33%. They increased the engagement with their existing customer base. They supplemented that with additional channels to expand distribution and ultimately send a lot less product to landfill. Now, Danone is a certified B Corp. They have, like many of their peers, public zero waste commitments. So this has become a core part of their operations and mission critical for their supply chain team. We at Spoiler Alert, also a mission-oriented company. This is why we love doing what we do. We have a lot of other case studies on our website about our work with Kraft Heinz, Campbell Soup, and others. Definitely recommend you check them out. And in terms of what we're looking for, always eager to start conversations with additional manufacturers within food and beverage, consumer goods. Would love to have the opportunity to speak with you later today. Thank you.
Hi, sorry. Anyway, so my name is Ali Merchant. I'm the CEO of IQ3 Connect, and we're using technology built at MIT with our web-based XR training platform. So people are the strength of an organization, and manufacturers spend a huge amount of money on training to stay competitive. But we're living in a new normal of remote work, challenges with sustainability, and also training a global workforce and ensuring that there's equality in training across global teams. And this is especially challenging for product companies that are building products with a global footprint all over the world. Because they rely heavily on hands-on face-to-face activities that are done in facilities and travel, and these are becoming more and more unsustainable. So what's the alternative, right? Today, the current tools are basically flat-screen tools that work for many industries, but they're very hard. It's almost impossible to virtualize the hands-on, face-to-face collaboration that is required in manufacturing. Can you imagine explaining kind of an assembly process using a Zoom meeting or a Teams meeting? It's pretty much impossible. So VR, AR today is very exciting and is getting a lot of traction in the enterprise, but the challenges are that these are more like gamified movie solutions that are very hard to scale, very expensive to roll out, and lots of lead time. So you can spend $500,000 building a training example, but it does not scale. And that's why we built a very simple and practical solution that anyone can use today, and that's built on technology that was developed at MIT. And this is IQ3. What you see here is an IQ3 workspace, and basically all you have to do is click on a link, and it opens up in your browser just like a Zoom meeting. And you can deliver fully collaborative global training on complex processes, complex products in this web-based workspace. And our technology makes it very easy to do this in a browser and ensure that we can do this at scale with very low latencies, and your training can be delivered pretty much anywhere globally, anywhere around the world. And not only do we make it easy to use in a browser, in a simple browser environment, but it's also very easy to create training. And even my son was able to use his IQ3 today to create learning experiences for his class. The point being that large enterprises can scale this up very quickly and cost effectively for their complex training and product development needs. And so here are two interesting case studies that we are working with the leadership at the largest edtech company in the world today, and they use videos, and now what we are doing with them is building, in this web-based, browser-based solution, a highly interactive learning environment that can deliver measured results. And as you can see here, this is from a video now to a highly 3D environment that you can consume on a VR headset, you can consume on a tablet, or a laptop. And then here's another example, working with one of the largest consumer companies in the world, and they also face the problem of training technicians, and there's huge amounts of turnover, and it takes weeks to train greener and greener employees that are coming into the workforce. And so what we're doing is now replacing the old-fashioned ways with highly interactive, measurable training and ensuring quality across their training needs across different product lines. So here's an example of something, and you can have a live experience of this if you come and find us later on at our demo table. And so we have a platform, and we're doing a lot of interesting pilots, and we would invite everyone here in this manufacturing and enterprise industrial space to come and talk to us. We'd be happy to work with you, use our platform to create pilots and really understand. It would be a mutual learning experience for us and for you to really think about how you can transform training beyond the traditional tools that are out there, like face-to-face classrooms, videos, and other document-based learning approaches. And we're quite industry agnostic, although we are mainly focused on manufacturing companies at the moment. So please come and talk to us later on after the demo table, see an exciting demo, and let's explore potential opportunities of using our platform and technology. Thank you very much.
Hi, everybody. Nice to meet you all. My name is Emanuel. I'm the co-founder and CEO of Einblick Analytics and a former postdoc at MIT here. So at Einblick, we're building a data science platform, and it's based on 6-7 years of research we've done at MIT and Brown University. And one of the things that we wanted to achieve during the research was to make data science more accessible to a wider range of users. Make it more intuitive, make it more collaborative, and frankly, also just make it more fun. Along the way, we always were heavily inspired how data science workflows are depicted in science fiction and movies. So here, for example, you see this short snippet of where domain experts collaborate closely together on a large touch wall. There's no code behind it. Everything feels natural and intuitive. And these folks can really focus on the problem at hand that they're trying to solve without getting distracted by technical problems there. But when you look how data science is done today, the picture looks quite different. Very code heavy. People work alone on data science problems. There's very little collaboration between domain experts and technical experts. And even if you might take sort of the latest and greatest in terms of data science workflow engines, the picture doesn't really change that much. So our goal was to kind of, bring the vision and the science fiction a little bit closer to reality. And to do this, we had to kind of innovate in 3 core areas. Started out with, completely rethinking the user experience of data science tools from the ground up, where, it's easy to collaborate, everything's snappy, you never have to wait long for results, even if your data is really big, et cetera. To kind of achieve that user experience, we envisioned we had to innovate a lot on the kind of back-end processing side of things too, where we've built what we call a progressive approximation engine that allows you to execute various workloads ranging from simple SQL-like visualization type queries all the way to complex machine learning workflows and sort of seamlessly scales from small data to large data sets. And then finally, we also had to innovate a lot on packaging up, common data science problems and algorithms in easy to use visual operators than you could use in the platform. Today, we're working with quite a few customers in the manufacturing sector, on various different use cases. The one I want to highlight here is one where we're working with a large car manufacturer, more specifically with a production line manager that knows a lot about cars, so is a deep domain experts in building cars, knows a little bit of SQL, is kind of data savvy, but definitely not a machine learning expert, never built a machine learning model in his life, and doesn't know sort of the usual data science stack, Python or R to do so. So, his scenario was, cars are very complicated to make, parts come from, all over the world, from many different suppliers, and each car can have, thousands of different options when it's built. And obviously mistakes can happen sort of in this process of the assembly line, and his task is to kind of improve operations on the production. And he was interested in, seeing if he can use AI and ML to sort of achieve that goal. So core task there was to, kind of identify risks in the supply chain, being able to, in real time, predict delays on the on-time delivery of these cars, and also estimate impact of, staffing shortages on delivery times of cars. And so, successful use case here where, within a day, this particular person here was able to build a model for some of these tasks that they were working on, and within a week was able to productionalize the tool and run these kind of what-if analysis in real time to solve some of these challenges. If any of this sounds interesting to you, if you have issues hiring data scientists, or you want to upskill your current workforce in terms of being more data-informed or data-driven, then come talk to us. As I said, we work with quite a few companies in the manufacturing sector. The platform itself can be used for free online. It's a SaaS-based product, but we can also deploy on-premise if you have sensitive data. So please feel free to either try it out online, or we have a booth here, and we'll be happy to walk you through a demo. Thank you.
Hi, everybody. Thanks, MIT and Ariadna, for throwing this all together. It's been great. I love the discussions and everything that's going on here. My name is Dave Landry, CEO and co-founder of Datawheel, and we build automated reporting systems. We like to say our background is in the intersection of design, academia, and technology. So I'm a traditional graphic designer that discovered visualization. I founded the company with Cesar Hidalgo, a former MIT Media Lab professor, and Alex Simoes, who's going to be joining me at the booth later, who's a computer scientist in this space. And we kind of all overlapped with this idea of data exists, we're all collecting it, but it's really hard to use. And so we start to bring that human element into it. So the current paradigm as we see it is everybody's collecting data, right? We almost have too much that we know what to do with it, right? And then there becomes that problem of how do you ask questions of that data? We give if you can see it on this screen here, the data like warehouse analogy. So if you go to a big box store, you don't necessarily start in the warehouse. You want to see the showroom. What kind of living rooms can I build with this data? That sort of thing. And that's what we're doing and we're building. What if we can organize this data in a way so that we can, on the fly, ask specific questions of this data and present it in automated reports so that every week you could log into a system, say, what's the current status in San Francisco, or how's this specific sector in my company doing? How we do that is we transform data into stories. So we typically engage with clients, and we're trying to figure out what questions are you asking of the data. We have a content management system that drives these automated reports where you're essentially typing in variables as you're typing. So we can pick a location or a specific sector. We build one page for that, and then it rolls out for all the different sectors there. So we do have experience with data transformation in ETL. We've found that all data is different, not only as subject matter, but in how it's being stored. We've had clients who have Excel files, people who have databases, people who have Power BIs, and these analytical systems already set up. We can tap into that. As long as we can pipe the data out there, we can start to build automated reports. So what does that look like? I show an example here. It's kind of a good use case. We work for Verizon every year to publish the digital version of their data breach investigations report. This is a report on all the different industry sectors and the different patterns of attack that they're able to monitor on their network, and they publish this back to their enterprise clients as a report. Now, traditionally, that's like a 90-page PDF, right, that they put on their site. You're limited with number of pages. You're trying to retain attention here. What if someone just cares about the manufacturing industry? They have to go find which pages have that. And then you don't have that fine-grained control. So we built a digital companion to that. So now you can go to a page for any industry, see data specifically on that, and actually interact with it, right? So this idea, and I think at this example here, I have a thing there with a drop-down with 6 options and a double little toggle. That's 12 different charts you can make in one space. You're kind of limited in a PDF. That takes up a lot of real estate. You have to be much more selective and choosy here. So this gives a deeper dive into your data on the fly. Another good example here is we do also work with public organizations and governments, and we're currently working with the Secretariat of Economy in Mexico to build sort of their open data platform, looking at census data, economic data, industrial data, education data. And they've already had some great use cases of this where they have foreign direct investments. They meet with them, they come, they see, well, can we work together? They're able to look at this tool, say, well, what are you trying to do? Let's look at that sector. Well, let's look at that sector in a specific geography. And they're able to attract that investment instantly, just having this tool there at their fingertips and not requiring, oh, we'll put a report together and we'll get back to you in 2 weeks, right? This becomes like a tool that they can leverage on the spot. So what does that mean? What are we looking for? We look for collaborators here. I talked a little bit about this human element, both in visual design. We do take pride in making things look pretty and easy to understand, but easy to understand touches upon the content design, really. there's so much data, you could ask a million questions of it. Really honing down and defining what are the important questions that you're asking repeatedly of that data. Let's free up the data analysts to do their deep dives and do their research so that stakeholders, C-level folks, they have a tool that they can just quickly log in, see a snapshot on different parts of their business, and then make informed decisions based on that. So as Datawheel collaborates, we do an iterative design process where we'll come up with sort of the first draft. We did a little research into your data that you let us see, and we think this is the best way to lay it out, and then it's just a back and forth for usually typically 4 to 8 months is a typical collaboration, where we iterate on that. And you might say, oh, we don't talk about this way, can you put these buzzwords in there, or this looks formatted a little weird, or we thought we could do a bar chart, but maybe we switch it to a line chart. And then at the end of the engagement, you have this easily searchable tool that anybody can use, and we also hand over that content management system. So down the road, if you want to add a new chart or change up something in there, you have full kind of admin access behind there. So come talk to us at the booth. I think doing a live demo helps out a little bit, and myself and Alex will be there to talk with you. Thank you.
So that's it for the startups. Thank you so much for your participation. It's quite a mix of technologies, so hopefully you'll engage with them now that I invite you to the lunch exhibit. It's going to be a nice lunch, but also enough time to talk to all the startups and find out more. And thank you again for joining us. We really appreciate it, and it's great to have you here. And please be back at 1:50 for the next session.